Alright, so welcome from the former video. We ended on this note that we're going to be working with this bar that has all the coefficients of our expansion when n equals 3. So we are taking that bar away now, and we are going to be working with it on our working page here. So we have the bar out already. Now let's do binomial expansion. Okay. How do we start? We start by bringing this one. Okay. Now the one is out already. Then in this bracket, we're having just two terms. The first term is an alpha, and the other term is a plus beta. Okay. Now that we have brought out this first coefficient, which is 1, then let's bring out the first term in this bracket. That's an alpha. Okay. So this alpha now is going to be carrying this power of 3. Okay. The next thing is, let's bring out this second term, beta. But beta will be carrying the power of 0. Okay. Don't worry, you understand. Now the next coefficient on our bar is 3. So the 3 is coming out already. Now the next thing we'll do is, we are also bringing out this alpha. But this time around, alpha will no longer be carrying the power of 3. It will reduce by 1. Okay? So that's going to be raised to the power of 2, just like you see it. And now beta also will be coming up. But this time around, not with the power of 0. It will be carrying the power of 1. Okay, that's the principle. Now, alpha here is 3. Getting here, it decreases by 1. Beta here has a power of 0. Getting here, it increases by 1. So as one increases, the other decreases. So let's move on. The next coefficient is this second 3. So we're bringing it out. So let's bring out the first term. That's alpha. Now alpha now will be carrying the power of, what do you guess? Of course 1. The power of alpha decreases, while the power of beta increases. Now, beta is coming up to be having the power of, what do you think? I think 2. So, this is, alpha is having 3, 2, 1. Okay? While beta is having 0, 1, 2. One increases, the other decreases. So, we are done with that. And the last coefficient here is 1. So, let's call it out. So, it's coming out already. Then we have our alpha. You know, alpha, the power of alpha is decreasing. So it's going to decrease to what now? I think to 0. And beta is coming out. This is 2 here. It has been increasing. So it's going to increase to what? To 3. Now, watch out for the addition of the powers on each of the terms. The first and the second term in our bracket, we are expanding. You will notice that by the time you add of the powers, here is 3 plus 0 is giving this 3. Here is 2 plus 1 is giving this 3. Here is 1 plus 2 is giving you this 3. And here 0 plus 3 is this 3. Now, that shows that your work is accurate. Now, what is the next thing? The next thing is that let's get rid of every coefficient of 1 and everything that has the power of 0. We don't need them. Alright, here is 1 multiplied by alpha raised to the power of 3 multiplied by beta raised to the power of 0. What do you think is the value? 1 here has adding no value to this multiplication. And this beta raised to the power of 0, remember, anything raised to the power of 0 is 1. So we need to get rid of this 1. And we need to also get rid of this beta raised to the power of 0, because they are both 1. So we are done. That's just 1 multiplied by alpha raised to the power of 3 multiplied by 1. So what's the point? Our answer is alpha raised to the power of 3. Now let's come down here. Here is 3 multiplied by alpha raised to the power of 2 multiplied by beta raised to the power of 1. So, what can we do now? Let's get rid of this power of 1. Beta raised to the power of 1 is the same as beta. So, let's get rid of that 1. We don't need it. Here is 3 raised to the power of 1 multiplied by... Here is 3 multiplied by alpha raised to the power of 1 multiplied by beta raised to the power of 2. Okay, so let's get rid of this power of 1 on alpha. And what other thing? There's another coefficient which is 1. And here is a power of 0. So here is 1 multiplied by beta raised to the power of 3. Alpha raised to the power of 0 is 1. So that's 1 multiplied by 1 multiplied by beta raised to the power of 3. We don't need those ones. So our answer is beta raised to the power of 3. So what have we been able to do? So we've been able to clear every excess that is not needful. So the next thing we do is, let's bring down these values. Just adding addition sign here, addition sign here, addition sign here. Then that's what we have here. Okay, putting an addition sign here, an addition sign here, an addition sign here. Then we have this. Now with my expansion, just take note that I've been able to generate an alpha raised to the power of 3, which is this, and a plus beta raised to the power of 3, which is this. Maybe you're not seeing that already. Yeah, I've been able to generate that. And I'm optimistic that I'm getting close to a destination, a very good destination. So with that done, let's see. I have a value already in the middle that is already dancing. Okay, dancing because you need to leave this side and move to the other side. So let's see how it works. So this is alpha and beta already coming out. So this alpha and beta already coming out, just like you see them come out. Okay, so every other thing in gold there will be moved to this side. Okay, so they are moving already, but they won't just move because they have crossed the equality sign boundary here. So because they've crossed, the two addition sign that accompany them will change to negative. You agree with me? Of course, you should. This addition and addition crossing the equality boundary to the other side, they are going to be changing to negative, and that is why I have things changed for me. So in alpha plus beta raised to the power of 3, I believe you know how I got how this alpha plus beta all raised to the power of 3 is there. Is from this one. Okay, so I just need to rearrange, bring these golden values, bring it down here, push this equality sign forward, which is this. I just do rearrangement. Oh, now alpha plus beta all raised to the power of 3, and what's the next thing now? Everything here must conform to alpha plus beta or alpha beta. Alpha plus beta is already conformed to one of the values I need, but all these values, they also have to conform to what I need, and I can only get that done through factorization. Wow, I said that again. I can only get that done through what? Only through factorization. So let me see how far I can go on that. So what do you think is common to these two values? Sorry, to these two terms. Here is a minus 3 alpha squared beta. Here is a minus 3 alpha beta squared. So what is common? A negative is common, I think. I'm bringing it out already. I think a 3 is common. Okay, here is alpha squared and here is alpha. So from the two terms, I can get a alpha common to both. Here is a beta and here is a beta squared. So from the two terms, I can also get a beta common to both terms. We have 2 alpha here, we have 1 here. So 1 is common to both. I have a beta here and having 2 beta here. So a beta is common to both. So what other thing do you think is common to these two terms? I think nothing. So if there is nothing, then let me try and do a quick factorization here, and I've brought out the highest common factor of the values. So, alright, minus 3 alpha beta that I brought out here is the one here. So I brought this out from here. I brought minus 3 alpha squared beta minus 3 alpha beta squared from here. Then factorizing into it, minus 3 alpha beta, the one I brought out here. Then let me close the brackets. So closing my brackets, I'm having this first term divided by my factor, and also having the second term divided by my factor. Okay, we have been following well on our factorization series. That is how we do it. Okay, factorization of long algebraic terms or factorization of short algebraic terms. This is a strategy we use then. So let's do our quick division, and how does it work? So I'm having minus 3 alpha beta outside there, then open my brackets, doing the division. Negative goes for negative, 3 goes for 3, a beta goes for a beta. Now I'm having alpha squared here, up here, and I'm having an alpha here. So doing the division, this power of 2 will go for this one. If it goes for negative, it becomes a positive. Negative goes for negative, it becomes a positive. 3 goes for 3, alpha goes for alpha. This 1 beta here goes for this power of 2. And I'm left with just 1 beta. Then, and I'm closing the bracket. Now, I want you to do something. Open this bracket and see if you won't get what you have here back. Open this bracket. You will surely get what we have here. Okay? So, what do I need to do now? Let me continue my work by bringing in this value here, alpha plus beta. I need to bring it down here. Then close the brackets. I think what I did is understood. Yeah, it's understood. So, this term minus 3 alpha beta into this open bracket alpha plus beta is just equal to everything here. Then equal to the values I'm looking for. Okay, with what I've done, have I been able to make every bit of term conform to alpha plus beta and alpha beta? Have I? I think yes. So this is alpha plus beta that can easily be substituted for minus b over a, and here is alpha beta that can easily be substituted for c over a, and this is alpha plus beta again that can easily be substituted for minus b over a. So I've achieved what I need to achieve, and that's an answer. But remember, I said we're going to be taking 2 approaches. This is just the binomial expansion, and here is another approach. Let's take a look at this and let's see how it's going to work out. Alright, I need to do this expansion. So in my expansion, I'm bringing out this already. So in my expansion, I need to expand alpha plus beta multiplying alpha squared plus beta squared. So how do I do that? I need to bring out this alpha, which is the first term. Okay, then bring out everything in this bracket, the normal expansion. Here is plus beta, the second term in this first bracket, then write out everything in the other bracket, which is the same as this. So let me do a full expansion. This, removing this bracket, I'm going to be having alpha raised to the power of 3, and this multiplying this will give alpha multiplying by beta square. Now the same thing here, that's going to be alpha square multiplying a beta, and I'll be having alpha raised to the power of, and I'll be having plus beta raised to the power of 3. I think I'm getting my answer already. Okay. And that's the same thing I'm having down here. That's the same thing. What I'm having here is the same thing I'm having down here. So why some terms in gold? Why some in white? I need to leave these ones in white so that I'll be able to separate them. Can you see now? The 2 values I'm looking for, or the 2 terms I'm looking for, they are already out, coming out already. So let me bring them out, and yes. Then the equality sign following them. The values in gold, I need to bring them down to this other side. Okay, they're dancing already. So let me bring them down to this other side. Okay, but they won't remain addition. They should change, of course. Or they're already changing to negative sign. Okay, now here is my value. Remember, I expanded this to get this. Okay, now after expanding, I try to bring out this alpha raised to the power of 3 and this beta raised to the power of 3. I try to bring them separately to this other side of equality sign. Then the remaining values that I need to work with, I bring them to this other side, and I have this 2 positive sign change to negative. Remember, all these have been on this side. Okay. So then I need to do a factorization. If an alpha is here and an alpha here is raised to the power of 2, what is common? An alpha is common. And beta squared is here, and I'm having just beta here. So I also have 1 beta common to both of the terms. Any other thing common? Negative is already here. Now let's factorize. Now, in my factorization, I'll be having a beta. This is a negative dividing a negative. That's going to be giving me positive. And here I'll be having an alpha, close the brackets. Then I'm having what I have on this side. Just to see the place of factorization in what I want to do. Okay, so with that done, let me see. Here is alpha plus beta. Remember, we already had a value for alpha squared plus beta squared in one of our previous work we did. So that value is, remember this value, alpha plus beta all squared minus 2 alpha beta. That is the value we have for this. So can we bring it in? Can we substitute this value for this in that work properly? So let me bring in that value, and the value is alpha plus beta squared minus 2 alpha beta. That's the value of this term in red. And I'm also rendering it in red. So the next thing is I'm bringing out this value, just like we can see it on our screen. This is the whole thing I'm bringing out here. Then equals alpha raised to the power of 3 plus beta raised to the power of 3. I just want to believe what I did is understood. Alpha plus beta is this value. The whole of this value is there. Okay? And this minus alpha beta, then beta plus alpha in the brackets. So with this done, I think I've been able to write everything I need in conformation to alpha plus beta and alpha beta for my easy substitution, I think. But there is a reason I'm disturbing my head around this. Sorry if I'm also disturbing yours. I just want to show that you can use this binomial expansion and you can also use this method. Okay? So, I already got a value for this term the other time using this approach. Now, using another approach now, let's see. These values I got, are they the same thing? Let's expand this bracket. These two terms, this and this. So, I'm multiplying alpha plus beta with what is in my square brackets. So, doing that, I'll be having alpha plus beta multiplying by alpha plus beta squared. And that's going to be alpha plus beta all raised to the power of 3. Which is this. Now, I'm picking alpha plus beta again to multiply the second term in the bracket. I'll be having a minus 2 alpha beta multiplying what? Alpha plus beta. Just use this value to multiply this bracket. This is what you get. Then remember, I'm having something out here already. That's minus alpha beta. And I'm having it down here. Okay? Then equals alpha plus beta. I think I've not committed any crime. I just believe I've not. Now with that done, let me see. Is there anything to be added or subtracted? Do I have anything of the same term? Here is minus 2 alpha beta, open bracket, alpha plus beta, close bracket. Here is minus alpha beta, open bracket, alpha beta plus alpha. Do you think what I'm having here is the same term with what I have here? Alpha beta, open bracket, alpha plus beta, close bracket, open bracket, beta plus alpha, close bracket. So, this beta plus alpha and this alpha plus beta, do you think they are the same term? Of course, they are the same term. 2 plus 3 is the same thing as 3 plus 2. Yes. But 2 minus 3 is not the same thing as 3 minus 2. They are not the same thing. So, I'm saying that to show that alpha plus beta is the same thing as beta plus alpha. They are the same term. So, I'm having minus 2 of this term and I'm having minus 1 of this term. Adding together, what do you think I'm having? So, I'll be having alpha plus beta raised to the power of 3, then minus 2 minus 1. That's going to be giving me minus 3. Which is exactly the value I got using this first approach. The binomial expansion. I think I've not disturbed your head too much. This is what actually made this video one long one, okay? And I think it's been wonderful, okay? I'm sure it's been wonderful. I'm doing this just to show the beauty in math that there is no one way to what you're doing. Just try to think and, you don't need to cram all this in an examination or just know. In fact, I would prefer the second method to this binomial expansion. because I won't advise you to cram this. You can easily forget anything you cram. But once you know the way out, the way to your destination, just put up some things and you'll get your destination safely. Now I've used two approaches and I'm getting the same value for both. Okay, now I've not answered the question I'm giving. I've gotten the same value for both approaches now that I used. Sorry, for the two approaches that I used there, which is alpha plus beta raised to the power of 3 minus 3 alpha beta open bracket alpha plus beta. So now substituting for alpha plus beta and alpha beta, I'll be having, that's minus b over a here, like I'm having it here, and I'll be having minus 3 c over a, because alpha beta is c over a, and alpha plus beta again is what? Is minus b over a. So what have I done? Anywhere I say alpha plus beta, I bring in minus b over a. Anywhere I say alpha beta, I bring in c over a. And that is what I've just done. Because the instruction is that I should express this value in terms of a, b, and c. But I must first express every term in it, making sure that they conform to alpha plus beta and alpha beta. Otherwise, I won't be able to do the work. So let me proceed and see how to tidy things up, if possible. So I'm having minus b over 3, or minus b over a all raised to the power of 3 plus 3bc over a squared. Okay, why the plus? Here is a negative multiplying this negative. It's giving you a positive already. Okay, here is minus. This minus cannot change because it's raised to the power of 3. So that's minus by minus, that's a plus, and that plus by another minus. Still remain what? Your minus sign. So a better way of putting this is, you can just put this forward, what I have here, that's 3bc over a squared, then later come and write this, minus b over a squared. And you'll find, this is my answer. Okay, not to bore you with too long video, let's start the next question in another video. If you are new to the channel, remember to subscribe and do share with a friend that you know can benefit from this particular work. I will see you in 3.
Brethren like you, Jesus master lover, Jesus master lover, teach us my love.